Hello, my name is Sam Hassan from Strategic Information Systems Group. This is a presentation prepared for Duke Energy to give an overview of Strategic Information Systems Group capabilities in the energy sector, which is primarily where we focus on. We're an IBM and Oracle business partner, and we basically provide a solution for the energy sector, particularly in creation of operational data stores and dimensional models derived from that operational data store for the purposes of analytics, connecting to all the smart metering and other types of devices such as substation automation devices, so that analytics can be performed on that information, as well as supporting integration to outage management and transmission and distribution systems from various types of SCADA devices that collect voltage, current, data quality, harmonics type information, analog and digital, for subsequent analysis, again, or integration into the operational environment. I'm going to begin with just a quick walk through the website, just because you can go to that website and peruse it at your leisure. But I do want to point out a couple of highlights which I think that would be important, that we would like to emphasize, and so that you can get a better feel for some of the things that we've done in the past and some of the things that we're doing now. On the home page, we want to direct your attention to About SISG, which tells you a little bit more about who we are, Dave and I, the principal partners in the company. Something about events, which we talk about the IBM Innovation Centers, where we have many of our processors and support teams for various solutions, including non-IBM hardware and software integration solutions. We have development centers in the United States, in Chicago, and in Hursley, England, which is a huge IBM data center where we have many of our analytics and operational type systems and proof of concept data centers capabilities. I've attached a white paper in the email itself, so I'll tell you a little bit more about specifics. But again, this is just a quick overview of the website. If you go to the Utilities tab in the upper left here, talk a little bit more about the CIM, which is Common Information Model, which is a reference model in our practice, which is basically related towards energy, gas, electric, and water utilities, emphasizing that reference model, which has been built over many, many years by many, many engineers, and it's an international standard for data integration in the area of power generation, transmission, distribution, and following standards for data storage and collection and dissemination, as well as messaging for purposes of integration. Many of the vendors that we talk to, such as General Electric, Siemens, Landis+Gyr, Springfield Networks, Itron, and so on, do follow this standard for integration of their devices and signal and other types of analog and digital information coming from the devices, again, following that standard. And what we've done is basically follow that standard to collect that information for storage into the operational data store. Again, support integration or downstream analytics in a business intelligence environment, which can be accessed by either Cognos Business Objects or just pure SQL. Our primary emphasis, again, is business analytics, predictive analytics, including SPSS, statistical analysis, regression, time series analysis of various types of signal information. And of course, we build data warehouses. We're more of a Kimball, Inman types, where we have information factory, atomic data warehouses, data marts, and the classic types of data warehouse practices and best practices that are followed in the industry. Of course, we adhere to. We have been personally trained by Ralph Kimball many years ago, and of course work very closely with Informatica Corporation, Data Stage, and of course the Data Stage people, Central Data Stage people, and Oracle and IBM. So just a little bit about that. On the technical architecture, don't want to spend too much time on this now, but it's because of the virtualized cloud capabilities that we see today, we do have the ability to become extremely agile in deploying many, many servers that bring in databases up for development testing or performance purposes for many development initiatives concurrently. Again, in a very agile manner, because of the virtualization, these servers and databases come up in a day or two, and what used to take us probably a month or two to do. And if they're virtualized by cloud and self-provisioning, again, the normal red tape for getting the system administrations and the database groups to assist us in deployment of those infrastructures is vastly simplified due to the new virtualization of hardware and cloud capabilities, specifically on-premise clouds, not necessarily ones that are out in the virtual clouds. On the agenda now, I'm going to move into the common information model and just a quick overview of the capabilities and how that reference model is used in development of products and services by SISG and how it's used at typical client sites. The common information model, again, is an international standard developed over many, many years by many engineers and business people around the world. And many manufacturers adhere to that standard, the people that are building transformers and transmission lines and reclosers, all the meter vendors such as Siemens, Gear, General Electric, so on and so forth, appear to be adhering to that. If you go to the big trade show, Distributech, for example, you'll see many, many vendors who endorse the ability to provide signal and other types of information using this standard, and of course collecting that information in real time for, again, data integration and analytics is what we do. If you look at the basic packages in the CIM, you'll see 1970, which consists of the subject areas that are supported, for example, wires generation, the load models, SCADA type. If you look at SCADA, you can see the types of classes, if you will, or collections of business information and attribution that are supported by that particular package or subject area in the standard. And these are some of the attributes. The attributes, of course, in the database, which we will look at shortly, are much more elaborate. These are just skeletons prior to the integration of all the classes, which is what we do and how we come to build our database offerings and our solutions. Looking at remote units, obviously any type of remote unit type is supported, RTUs, substation controllers, IEDs, and so on and so forth. Communications is done by something called Part 9, which is really a standard XML messaging for moving data, which contains, for example, signal information or meter reading data or events, and of course identifies the premise and the service points and other information such as the customer, manufacturer, and the meter, and so on and so forth. If you look at the 1968, this is where the smart metering information is, and what I have open here basically is, I'll just open it again. It's the metering overview. Basically, it's the types of information that we get from our smart metering environments, and these are the classes, again, and some of the attributions that are supported in relationships. For example, we classify our end devices, and they could be any type, of course, into groups, and then the types of controls that they can process, the function of the metering, and so on and so forth. The end device classifications, including the manufacturers, the meter readings, of course, and the intervals in which they're read. And as you can see, the soft help that as I'm going over these, it's describing what those objects are. And if you click any of them, you can get the detailed definition of each of the attributes that are in there prior to being generated as columns in the database. Meter reading, of course, and the values of the interval for that reading, of course, is supported as well. So again, this is just a quick overview. What's really important is the database that's generated from this. And as you can see here, I am now logged into well, this happens to be a DB2 server, and this one is in New York at a New York data center, which is an IBM data center. And you can see that many of the classes have been converted to actual tables. So I'm sure we recognize AC line segments and phases, assets, conductors, types of information that are derived from that class model and built into physical databases. And of course, these tables in this database are loaded by direct connection to the head-end systems for various substation head-end devices or metering head-end devices, such as you see from Gear and Springfield Networks, Itron, so on and so forth. The types of information I'm going to just show here real quick are the end device events, and events follow something called the four-part ID. The four-part ID is really an international standard for the type of meter it is, the type of communication that's being provided, the classification of that information, and what the exact signal or value is. And those are the events that are coming in real time from those smart meters. And this is not to be confused with the meter reading itself, which is collected by information within the meter, and the meter reading itself, of course, has the reading type, whether it's estimated or not, the meter reading value, the interval at which it was taken, and the installation code for that meter, the type of installation that it is, and of course the meter ID, which is the serial number and the manufacturer, so on and so forth, and many other types of information that are in here. Of course, the usage points and the service points. In the case of the readings, the quality and the quality types, and the types of measurements that are taken are all detailed in here. And of course, there's a fairly elaborate substation automation environment that's supported as well, with again many other types of classes that are converted to databases that can be used to collect information about those assets in a dynamic real-time way for integration for analytics purposes. Going back to the agenda here, the next item that we want to talk about is the ETL. I just wanted to explain a little bit about how this works. Here we have, this happens to be loaded in real time with Informatica. The data is being collected from simulated events and smart metering generation products and loaded to the operational data store, which is the database that I just showed you. And as you can see, it's running in real time. And from there comes the dashboard that I'm going to show you right now, which again happens to be a Cognos dashboard. So if you look at it here, and I'm going to refresh it right now. As you can see, it's running. It's, according to my laptop, it's now 12:22 on the 25th. I'm going to refresh it and make sure that it says that, because it's 12:06 there. And I'll refresh it again. And so this is being loaded in real time, and when the user, be it an end user, analytics user, transmission, or distribution manager or director who wants to monitor the kinds of information that we want to produce to ensure data quality and meet specifications for MAFI, SAFI, and CADI, and the rest of those quality measurements for outage and length of outage can be monitored here. In this area here, we see these are the real-time meters, and again, they're being replicated here, but in a different icon, which is basically a speedometer type dial. The events, of course, are the types of signal information coming from the smart meters or devices, which basically describe whether it's an electric meter or gas meter, and whether it's a communication or other type of domain. The subdomains are things like power factors, power quality, and the action is I'm connecting, I'm failing, I'm being pinged by the CSR because I'm on the phone with the customer, and the customer is got a hypo complaint, or maybe the manager of distribution is concerned about fraud. So they're looking at types of events such as power up, power down, last gasps, and get an indication that there's tampering with the meter, and so on and so forth. And so this is just a little bit of a quick dashboard we put together just to demonstrate the nature of the data that's collected in the operational data store from the devices. And again, the types of information can be represented in the analytics environment. These speed dials can be controlled and filtered by this selection slide bar, and you can, for example, focus on 1 meter or a series of meters or a range of meters. And the same thing for the meter readings. You can focus on a specific customer or group of customers. You can zero in using these slide bars, and which essentially filters what you see here. So, for example, in the meter reading, I'm just going to focus on meter 567, and hopefully it'll just come up with 567. And 567, it should show a couple of meters, because we're not just presenting the information from the smart meter the meter reading itself, but also by the type of installation and the last activity that occurred on that, the last activity that occurred when that reading was taken. You know, whether it was done through a new install or whether it was done as a result of a disconnect or, again, those kinds of things. It's taken a little while to come up here, but hopefully it'll come back. Let me come back to this. I'm going to come back into the presentation here, and basically what we wanted to do is talk a little bit more about next steps. I've enclosed a link below that describes more fully our solution. And again, our solution can be used as a product or as a foundation for JRPs and JAD sessions, which can flesh out more of the requirements and the priorities of help organize the priorities of work and the estimates for the work. For example, in an agile environment, the number of sprints you might want to do can be oriented from the product, and which would drive the JRP, and users would drive the nature of the priorities and the sprints that would be done in what orders, and again help estimate how long it would take to do some of the things that are that the users are requesting, but more importantly, really expediting the amount of time, really reducing the amount of time that is that it would take to deploy some of these solutions, because you're using a reference model as a foundation, and of course SISG resources, which are thoroughly trained in most aspects of the energy industry in the area of requirements analysis, analytics, predictive analytics, and statistical analysis. Also, there's an attached in the email a white paper, which again gives you a little bit more detail in a different format. What we want to close with basically is really a request to visit Duke and do a real deep dive into what we've shown here, and we can either follow up with a more deep dive through a GoToMeeting or on site at your leisure. And then anything we do recommend and anything of interest to Duke, of course, can be performed in a POC and POT, proof of concept or proof of technology, long before any commitments are made to a particular approach, architecture, or how SISG would work in the environment at Duke. It can be demonstrated at our briefing centers, and where SISG and IBM executives could be there and talk a little bit more about statement of direction of how this product's evolving and how it takes advantage of, at least in the case of IBM, how it would be deployed in their virtualized environments and optionally cloud. So I will follow up with a call to make sure that I can answer any questions that you may have with respect to what you've seen here today. And I just want to see if that came back. Well, apparently it's not coming back, so not sure. Let's go into this the Informatica Monitor, see if it's still running. And well, it seems to be running, but I'm going to just real quick go back here. Try to refresh it one more time. See what happens. Let's see if it's loading again. Ah, came back. Okay, good. So here you see meters 567 and 569. Again, I just want, let me just bring up these 2 meters, 567 and 568, and see if I can get that to come up. You know, keeps wanting to go back to 569. I'm not sure what's going on here. But again, hopefully you get the idea that the content of the data can be displayed in many, many ways, using many, many analytical front ends, independent of hardware or software, and we do want to emphasize that. So we'll give a call in a few days, and perhaps we can answer any questions you may have after you've had a chance to peruse the website and looked at the link to the IBM Pure Grid presentation that we have on the IBM website, and that content there and that link. And looking forward to working with you, and we'll be in touch shortly. Thank you for your time. I did that a little quick, but I'll do a deep dive as much as you like at your option. We thank you and have a good day.